Okay, this video is from section 8.1 and it is about the Pythagorean theorem. We've used this on occasion in class already. We've talked about it a little bit, and most of you probably had something about it in Algebra 1, so it may not be totally new. But let's start by talking about right triangles. First of all, we can't ever assume a triangle is a right triangle just based on how it looks. They need to either tell us it's a right triangle or show us by the little symbol in the corner that it's a right triangle, but we really can't ever assume that it's a right triangle. But since we're assuming that this one is, well, we're not assuming, which it shows that it's a right triangle, and they told us it's a right triangle. So in this situation, let's make sure we get our labeling straight. These sides are called the legs of a right triangle. The line that is across from the right angle is called the hypotenuse. I can't spell today. Hypotenuse. I think I spelled that right today. I still remember my geometry teacher in high school used to draw a picture and like draw a little pot with flowers and say a high pot in use. And I don't know. I don't think it meant anything really, but it still sticks with me. So there you go. So the side across from the right angle is the hypotenuse, and it is also the longest side in a right triangle. Always, always. That's going to come up later. When we label our right triangle, we usually label our legs with the letters A and B, and C is the hypotenuse. In the Pythagorean theorem, it says C squared A squared plus B squared. That means that one of the legs squared plus the other leg squared equals the hypotenuse squared. And in this formula, C is always the hypotenuse. Always, 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 always. The A and the B do not matter. It doesn't matter if I all of a sudden label this one B and label this one A. It doesn't matter. You're adding them together. It doesn't matter. But the C must be the hypotenuse. So if they tell me that I have a right triangle, and they've given me that this side is a 6 and this side is an 8, and I don't know what this is, and my Pythagorean theorem says that A squared plus B squared equals C squared. Yes, I reversed it. It doesn't matter. That's the same as C squared equals A squared plus B squared. What I really need to remember is that the side across from the hypotenuse is C. So X equals C. The others don't really matter. So 6 is a leg and 8 is a leg. It doesn't matter which one is which. So I'm just going to fill them in. A equals 6, B equals 8, X equals C. A is 6, so A squared. B is 8, 8 squared. And C, that's an equal sign. C, we're calling X this time, and it's squared. Well, 6 squared is 36, and 8 squared is 64. Add those two together, and you get 100. To find the square root of this, I know X squared is 100, so to find X by itself, I have to take the root of this number, and the square root of 100 is 10, so X equals 10. What if, I drew it upside down, what if they give you this? Well, across from the right angle, longest side, this is C. A and B don't matter. We're going to call this one A, we're going to call this one B. Our formula says A squared plus B squared equals C squared. We're going to fill it in with what we know. We don't know what A is. We're calling it X. So that's what it is. B is 15, so we have 15 squared. And C is 17, so we have 17 squared. Now I'm going to have to solve for X again, so I'm going to subtract 225 from this side. And that gives me 64. X squared equals 64. So X equals the square root of 64. 64 is a perfect square, so X equals 8. So that's how you find out one of the sides. You do not have to use this formula just to find the hypotenuse. You can use it and manipulate it to find any side you want. Let's try one more. They gave me a right triangle, and this and this side is 5. What we have here is a perfect square. This side would be 5, and this side would also be 5. And my TV just turned back on for some reason. Sorry, had to go run and turn the TV off. Okay, my hypotenuse, long side, I don't know what it is. So, a squared plus b squared equals c squared. A is 5 squared, b is 5 squared, and I don't know what my hypotenuse is. We call it c squared, we can call it x squared. It doesn't matter. 5 squared is 25, 5 squared is 25. Add those together, you get 50. Well, x equals the square root of 50. That is not a perfect square. So we have to figure out how to maybe simplify that as much as we possibly can. The way we do that is we say, what can I change 50 to? Which factors can I change it to where one of them is a perfect square? Well, it turns out that 25 times 2 is equal to 50, and 25 is a perfect square. So I can take that out. That becomes 5, and the 2 stays under the radical, so we have 5 square root of 2. It wouldn't be proper to leave the square root of 50 in this case. That's kind of like leaving the fraction 2/4. Your teacher would have said you need to reduce. It's not a correct answer. It's the same thing. This is not in its simplest form. You need to go ahead and change it to 5 square root of 2. Okay, in some of the problems in this section, they're going to ask you to determine if a triangle is really a right triangle. They're not going to tell you that it is or isn't, and you need to figure it out. So they just give you some numbers, and they say, tell me, is it or is it not? Well, we can still use the Pythagorean theorem for that. A squared plus b squared equals c squared. Now, we've been saying that c is always across from the right angle. But C is also the longest side. So, if we don't know where the right angle is, if there is indeed a right angle, we don't know that yet, we can still claim that C is this one because C is always the longest side. So that's what I'm going to put in for C. And A and B don't matter. I'm going to say A, 8, and B is the 24. 8 squared is 64, and 24 squared is 576, and 25 squared is 625. And if I add those two together, I get 640, and that does not equal 625, so this is not a right triangle. We can also use the Pythagorean theorem to determine whether a triangle is acute or obtuse. If c squared equals a squared plus b squared, if c squared ends up being less than a squared plus b squared, then it is an acute triangle. Obviously, it's not right because they would be equal if it was a right triangle, so it's acute. If c squared ends up being bigger than a squared plus b squared, then we have an obtuse triangle. So let's try a couple out. If they give you the number 4, 5, and 6, and they say determine whether it is right, acute, or obtuse. Well, remember, we said C is always the longest side, so we're always going to plug our biggest number in for C. We don't know if it's a right triangle yet or not, but we're always going to plug our biggest number in for C. So we're going to say 6 squared equals 4 squared plus 5 squared. 6 squared is 36 plus 16 equals 16 plus 25. 36. I keep writing equal, but we really don't know if it's equal. That's just habit. 16 and 25 is 41. So 36 is actually less than a squared plus b squared. So it is an acute triangle. Let's see if I can squeeze another problem in over here. What if they gave you the numbers square root of 3, 2, and 3? Well, c squared is what compared to a squared plus b squared? We always plug our largest number in for c, so that's 3 squared. A squared plus negative 3 squared. 3 squared is 9. 2 squared is 4. Square root of 3 times square root of 3 is 3. So that is 7. So in this case, 9 is greater than a squared plus b squared, and this one is an obtuse triangle. So let's work a couple problems from the book. Gave me a triangle, dropped an altitude down, and they labeled it like this. 26 on that side, 26 on that side. I don't know what this is, and they told me that it is 48 from one side to the other along that bottom, the base of that triangle. Well, hopefully you're looking at this triangle and you're already just ready to tell me what this triangle is. What kind of a triangle is this? It's an isosceles triangle, which means that this line that they dropped down that made this perpendicular intersection is a bisector. And so not only does it create this right angle, so now we have two right triangles, because this is also a right angle, but this also bisects the base. So this side's equal to this side. So if the whole length is 48, then this side is 24 and this side is 24. So now what I have is two equal right triangles. I'm going to draw one of them over here. This is 26. This is 24. That's a right angle, and I don't know how tall that is. So I'm going to use the Pythagorean theorem to figure it out. I have x squared plus 24 squared equals 26 squared, because 26 is my hypotenuse. That has to be my c. X squared plus 576 equals 676. X squared, I'm going to subtract 576 from each side. So x squared equals 100, and the square root of 100 is 10. So x is equal to 10.